Welcome. Before us, we have a question in physics under radioactivity. The question reads, figure 9.1 shows the decay curve of a radon nuclide. So we are given a curve and we want to use the principles of radioactivity to answer some questions. Now let's look at the first question. So the first question is about defining nuclear fission. Now there is a nuclear fission and nuclear fusion, so never confuse the two. Fusion comes in when two or more nuclei join to form a single heavier nucleus. So to fuse simply means to join. Now if this simply means to join, what is meant by fission? So fission is the opposite of joining, which is the splitting. So this is where now the atom splits. We have a heavier atom which splits into smaller atoms, and not only are we going to have the fusion products but also energies produced. So say the splitting of a nucleus to release energy. Now there are so many definitions, or we can say there are so many ways in which we can define a term like this one. If what we can say the splitting or the breaking down of a nucleus due to neutron bombardment, so the energy is also produced. That's why nuclear fission is one of the ways in which electricity can be produced. Now we move on to question B1. From the graph, determine the original mass. So the mass before any decay. So how do we use the graph to determine the original mass? So the original mass is gotten from the y-axis because this is where the mass is. Then before the decaying, the mass was 80. So we can call this point as our initial. So this is our initial. This is where the curve is touching the y-axis. So to summarize, the concept is that you get the original mass of a substance where the y-axis is meeting with the curve. So this is our curve. So the point at which the y-axis and this curve are meeting is 80. And we can see that we are dealing with the mass in kilograms. So that is our original mass. So we say 80 kilograms. Now question 2, quantity of the nuclei that remained after 6 days. So after 6 days, we want to look at how much from the 80 remained. So how can we answer this one? So if you go in the x-axis, 6 days, this is time. So time is in the x-axis. So how do you answer this one? You go where 6 is. So this is our 6. Then you draw a dotted vertical line until you touch the curve. So the point is you touch the curve, then you turn 90 degrees to the left. So the point where the dotted line will touch the y-axis is the mass that remained, which is 10 kilograms. Then the last question is, how can we use the graph to find the half-life of the nuclei? So the half-life is just the time taken for half of the substance to fall, or for the substance to decay by half. Now how do we find the half-life given the curve? So the symbol for half-life is T with the half here. So it's 1 half multiplied by, in our case we'll say original mass, or the original substance from the y-axis, which is half times so the original mass is the number that we are going to put here, so multiply by 80. So half of 80 is 40 kilograms. Now this 40 kilograms is not the final answer, so we are going to use now 40 kilograms to identify the time. Since this is mass, the half-life is time, so we are going to use 40 grams to locate the time in the x-axis. So you go where 40 is. So the principle is similar with that of statistics. So you go on 40 kilograms, you draw horizontal line until you touch the curve, then you turn 90 degrees down. So the point where these dotted lines will cut the x-axis is the half-life. In our case, we have 2. So just say 2 days. So it depends with the units of time that you are given. Since we are dealing with time in days, then our half-life is 2 days. So this is how we can answer a question like this one. That's it for this video. Thanks for watching.